and smaller each year, with megapixel counts and other features increasing at a breathtaking rate. But step away from the consumer devices and there are some truly amazing cameras being used. In this video, we'll look at some of the most amazing cameras in the world today and coming soon. If you've ever used Google Earth, Bing, Apple or most other mapping applications, then you've been seeing images mostly captured by satellites in orbit at around 360 odd miles above the Earth. In 2014, a new satellite was launched called the WorldView 3, which is owned and operated by Digital Globe and is the first commercial satellite to have a 25 centimeter resolution. That means that each pixel of the picture is the equivalent of 25 centimeters by 25 centimeters, or about 1 square foot of the actual Earth's surface. That might not sound like much, but don't forget, the camera is 363 miles up in space. Whilst this is still not enough to make out details like people's faces or car number plates, it is quite a big jump from the 70 centimeter resolution that applications like Google Earth had to use before. Digital Globe still had to apply for special permission from the US government to sell the new higher resolution images on the open market. Such is the increase in the quality that the new system can reveal that it would have been classified before. The system can image an area the size of the United States in just 2 days and can see through cloud and smoke with its additional shortwave infrared imaging cameras, so that events like wildfires can now be seen in a way which would have previously been hidden by the smoke or water vapor from clouds. Now, if you thought that the WorldView 3 was powerful, then wait until you see the 1.8 gigapixel Argos IS. This is DARPA's Autonomous Real-Time Ground Ubiquitous Surveillance Imaging System, or just Argos IS for short. This system is able to track and record every moving object, such as people, cars, trucks and other objects of interest in an area up to 36 square miles from a height of 20,000 feet, and see objects as small as 6 inches across, which is about 15 centimeters. It is designed to be mounted onto UAVs, drones, planes, in fact anything that can stay above the target area for long durations. Now, you may be thinking that this uses some super high-tech camera system, but in fact it uses 368 5 megapixel camera chips that you would find in a normal mobile phone. These are mounted behind 4 lenses, and the images from all the sensors are combined into one large image equaling 1.8 gigapixels, which allows for a large coverage area but still being able to zoom in to see the fine details. The hard part is actually handling all the data. Because the system is a persistent surveillance one, all the data is recorded and at a rate of 6,000 terabytes of data per day. The system can automatically identify and track moving objects over an area the size of a medium-sized city, something which would take 100 Predator drones to do the same. The operator has to just select an area of interest to look at and the system will start tracking. Up to 65 separate zoomed-in windows of interest can be opened to allow targets to be tracked across the entire field of view. Although originally intended for military use in Afghanistan, it's thought that this could be used to track criminal suspects in civilian areas too. So now we come from the 1.8 gigapixel surveillance system to the Large Synoptic Survey Telescope, or LSST, currently under construction in Chile. At the heart of this system is a 3.2 gigapixel camera, which will be the largest ever created when it comes online in 2022. The camera, however, is no lightweight like the Argos IS. This 3-mirrored device weighs 3 tons and is the size of a small car. It has 189 sensors and has a resolution equivalent to 800,000 8-megapixel cameras. The single image that will be created by merging all the data from all the sensors would fill 1,500 full HD TV screens. In 2022, when the LSST starts to come online, it will begin a 10-year mission to photograph the entire southern sky every few days to produce the most detailed catalogue of stars and galaxies yet created. Because it can image the entire sky every few days, the differences in the images will be used to track objects like asteroids and the movement of galaxies in order to try and better understand dark matter and dark energy, which is believed to make up 95% of the universe. We've seen high-speed cameras capturing things like balloons exploding, bullets going through objects, even the first few milliseconds of an atomic explosion. But the world's fastest camera is so fast that it can even capture pulses of light as it moves through space. The camera, which has been developed at MIT's Media Lab, has an effective frame rate of 1 trillion frames per second. The average video camera, on the other hand, works at between 24-30 frames per second. In one experiment, the team used a laser to create extremely short pulses of light, which are then shone through a plastic bottle filled with a cloudy liquid. This creates almost a bullet of light, as the packet of photons are seen moving from one end of a bottle to the other. It takes the light just 1 nanosecond, or 1 billionth of a second, to travel the length of the bottle. The biggest problem with this type of imaging is that the image has to be made up one line at a time, so the process has to be repeated hundreds or thousands of times, and the separate slices are then combined into the video which you see here. That's fine for a scientific experiment in the lab, but for events which cannot be repeated thousands of times, scientists in Japan have created the STAMP, or Sequentially Timed All-Optical Mapping Photography method, which can capture an astonishing 4.4 trillion frames per second at a resolution of 450 by 450 pixels. Now that resolution is not much when compared to, say, an iPhone 6S, but the best slow-mo performance that the iPhone 6S can achieve is 240 frames per second. It would take the iPhone 6S 581.3 years to capture the same number of frames as the STAMP system can capture in 1 second. Now from the fastest cameras in the world to the smallest. Built by Medigas, the MicroCam is just 1.2 millimeters across and has a resolution of 224 by 220 pixels and is fully waterproof. Made for endoscopic work, the Scout Cam is so small that it can be built into a tablet like the Pill Cam. This can be then swallowed and travels through the digestive system whilst transmitting a video as it goes. The tablet includes the camera, a light, a battery and a Wi-Fi connection, and captures 18 frames of video per second. Normally the patient wears a belt which picks up and records the video signal for analysis later. This allows doctors and specialists to see what's happening inside the patient in real time without having to do surgery or use a traditional endoscope. NASA have also been using the camera with tiny invertebrate robots in experiments on the International Space Station to inspect areas that would otherwise be inaccessible. This super lightweight and low power camera now enables the placement of cameras where it would have previously been impossible.